Hi all, welcome to part 2 of the video lecture on database management system introduction only. So in the previous part we saw the terminology, what is data and what is database, and some of the different implementation of the database. Like you can see it everywhere, like from the traditional database application to NoSQL, multimedia databases, the geographical information system, data warehouses, those things we just saw some variations of the database. Okay, now some of the implicit properties of the database. So you can't say a random collection of data as a database. That I already told you. So at the first point we saw like database is a collection of related data. Now we are exploring that point little bit detail. So 3 points you have to keep in mind, right? So when I'm saying that it's a database, these 3 points should come into your mind. So these are all the implicit properties of any database. By default, these properties should be there. First one, a database represents some aspects of the real world, right? So there will be some really real world application. It may be some an enterprise or a university. Something will be there on the from the real world, and that is what we are modeling using database. Okay. So this real world upon which the database is being modeled is sometimes called as a mini world or the universe of discourse, which we are interested. So this terminology you might see in discrete mathematics also, this U0D, universe of discourse, or simply domain, right, upon which that predicates are being defined. Similarly here, the domain or the universe of discourse or the mini world upon which we are defining our database models. So that is the first terminology. Now as I already told you, any change in the mini world is directly going to reflect on the database also. For example, in a student database system itself, we saw an example, a new branch is being introduced, say BTech in artificial intelligence, something. Then accordingly, the database being maintained by the administrative people, they have to be changed, right? Because a new course is being joined, added, and accordingly, structure is to be changed. So faculty are to be mapped, students are to be mapped, right? So not only that, even small changes in the mini world, the upon which the database is modeled, that will reflect in the database also. They are in one-to-one correspondence. Okay. Now the second point you have to keep in mind is a database is logically coherent collection of data with some inherent meaning. A random assortment of data cannot correctly be referred to as a database. So this is something I already told you. Randomly, if I'm taking some set of data and I'm calling it as a database, that is meaningless, right? So there should be some inherent meaning, or the data should be related in some way, right, in a meaningful way that we are interested. That only I can call as a database. Okay. Now a database is, third point, database is designed, built and populated with the data for a specific purpose. For example, so student management system or the faculty management system, or say in an organization the employer management system, whatever it is, something employee management system, yeah. Like that, it should have some specific purpose, right? So meaninglessly you don't need a database. And also I told you, like I have a small I just want to keep the data of some 78 students of a class as a data, as a staff advisor. I don't know how to keep a database. Okay, simply I can keep the data in some Excel sheet, or somewhere I can store them and I can manipulate. Maybe I can do it in manual way. It may take time, but okay, because data is small enough. And also if you're looking at small shops and all, they are not using any database on background, right? So in your day-to-day life you are visiting different small shops, they are not using. But if you're looking at some big shops, maybe some this Amazon and all, they are having this database because they are dealing with millions of data. So they can't do it manually, right? And also they want maximum efficiency out of it, right? They want that analysis of the data and processing to be done in a very best way, so that is going to help their decision making process in the business. Okay, so if that analysis is not good, if that analysis is not to be done in a faster and efficient way, there is no meaning. Okay, so that it's going to directly affect their business. Okay, so that is the type of purpose they are having, right? So with the specific purpose only we will maintain this database, not for a small shop or something. We are not going to maintain it. Okay, so it should be meaningful. So it has an intended group of users and some preconceived application in which these users are interested in, like that. Okay, and of course that huge amount, that also matters. And now we are introducing something called a database management system. So that is the name of the course itself, data we saw, and what is database also we saw. Now what is this database management system? So now this is a software. So far we saw that random data, right? So which is having some implicit meaning as data and collection of related meaningful data for a special purpose we called as a database. Now how we are dealing with a database? I already told you, like from the database that analysis is to be done and useful information is to be queried, right? And how this is happening in an automatic way. Some software is going to help us for that, and that software is what we call as a database management system. We have to manage the database system, fine. Now, the database management system, or in short we call it as DBMS, is a computerized system that enables users to create and maintain database. So, you need a database for an organization. You should be able to automatically create the database. You should be able to automatically populate the database, and whatever queries are coming accordingly, you should be able to answer the query. And sometimes you don't want some data, you have to remove the data, update the table. Everything you should be done in a computerized automatic way. And for that we have some specific set of software we are already having. Maybe again it's software, somebody written it for us, right, using which you can do all those things in an automatic way. So DBMS is a general purpose software system, and specific and general purpose software. So this is general purpose software system that facilitates the processing of defining, constructing, manipulating and sharing databases among various users and applications. So among the applications which are being controlled by users, you should be able to define the database, right? What about its structure and all, and you have to populate, and accordingly you have to construct the database, and sometimes for queries and all you have to manipulate it, and you have to share among the data among the customers and all. Okay, so defining a database involves specifying the data type. So just like how you are defining a variable in your C, you will mention the type of the variable, right, whether it is an integer variable or character variable. Similarly, in our database also, what kind of data we are storing. Sometimes we will be storing numeric data, so the data type is numeric. Sometimes we will be storing this character string kind of thing, right, varchar, like that. So those data types you have to mention clearly, whether it is of date format or numeric data or text data or image. So different data types are there that you have to mention clearly. And how these are structured, like in a given table, say what are all the fields, how many are to be grouped, like that structuring you have to mention. And some of the constraint about the data. For example, constraints, I can just give a simple example. Maybe you are keeping details of employees in an organization, and you know that employee, there will be some minimum age limit, right? So maybe 18 plus, then only we can. So if somebody is below 18, we can't call him as an employee. Okay, so I have a constraint on the data, particularly that age data, it should be a value greater than 18. And also maybe that retirement age and all 60, if it is fixed for an organization. If somebody is having an age greater than 60, that is maybe some special purpose will be there, that is different. We can't treat him as a normal employee, right? So like that, for that age field, I am defining a constraint, like it should be a numeric value, some integer value. You can't keep a fraction for age, right? And it again further constraint, like it should be a value between that 18 and 60, for example. Okay, whatever be our criteria, accordingly we can fix such constraints over the data. Okay, so there will be a data type, and some structures will be there, some constraints are there, right? That about it. The database definition or descriptive information is also stored in the DBMS in the form of database catalog or simply dictionary, or and the description is something called as the metadata. So this is something like we have the actual data. Okay, details of students in a organization, in a university, like that. So there will be student name, roll number, admission number, class, branch, like that, which are all the courses, and the marks, many things are there. So that data we will keep. Along with that, we will keep something called the data about data. That is what we call as a metadata. Metadata means we have the data that we are keeping in the database, okay, and we are going to keep its description also. So that is what we call as a metadata. For example, if it is name, It is a collection of characters, say with the maximum length some 31 character, like that we can restrict, like. So it is a field containing minimum 1 character and maximum 31 character, like that. So what are all the description you want done? It is of string type, collection of characters will be there. And also in the computer hard disk and all, from this point to this point this particular data is being stored. Okay, so like that, minute details of the data and the time at which the data is entered into the database, right? So you will be manipulating the database with the data, right? So and when a new student joined after some 2 months of the class started, so we will mention like this is the date at which this particular data about this particular student entered into the system. So like that, all further descriptions of the data which are kept in the database, we call it as it data about the data, okay, metadata, we will keep along with the actual database, and that is what we call as the database catalog or simply database dictionary. So they can simply frame a question, what is metadata and database catalog. So metadata means data about the data, I mean the actual data we will keep in the database, right? Now the description of that actual data, descriptive information of that data, and its definition, like its data type and what are all the constraints imposed on them in hard disk, from where to where it is stored, like that, all minute descriptive information about the data is what we call as a metadata, and that also we will keep along with the what called our actual database. Okay, so the slides are looking static anyway. I hope you are following it. We are at this 4th point. Okay, so that description of the data is what we call as a database catalog or dictionary. Constructing the database is the process of storing the data on some storage medium that is controlled by DBMS. So basically in some storage medium which are DBMS is a software which is managing the entire database, right? So database management system. So that software will be controlling some portion of the hard disk or somewhere, right? Some storage medium where the data is kept. So under the control of DBMS software in some storage area, we will manipulate the, we will populate the data first, then we will manipulate, like that. So that about the construction part. Now once the data base structure is defined and the data is being populated, then we will start doing manipulation of the data, right? Manipulating a database includes a function such as querying the database. So querying, I already told you, so user may be interested on something, right, about the huge amount of data we are having, and that we will be querying, right? So querying the database to retrieve some specific data what we are interested, so the details of the students having CGPA 10 or details of the students who couldn't score that F grade, we want to improve them, right? So like that, for different purpose, some specific data we are interested, and that we will query from the database. So querying means we are having some specific query, like that, we are interested on some subset of information and we are supposed to get it, okay? So we will query database for that, and so it's coming under manipulation. And also sometimes we want to update the database to reflect the changes in the mini world, of course, and generating reports from the data. You know, mini world keeps changing, like new students will be joining, like that, the new course may be introduced, right? So those things, the structure you have to update also. And sharing a database allows multiple users and programs to access the database simultaneously. So that is about sharing part. Many people, users, in the sense, if you are having the student management system, all the students will be simultaneously, sometimes the result announced and all, the database being managed by the KTU, many students will be logged on it, right? And they will be able to handle it in a simultaneous way. But the degree of concurrency, that matters actually. Concurrent access to the database means how much parallelly many people are trying, right? What is the concurrency level, that matters. Sometimes we may allow maximum some 100 people to access parallelly or 1000. Accordingly the system complexity will increase, right? So if you are allowing more concurrency, concurrent access to the medium, that is a very robust system, okay? But it's slightly, its construction will be complex and costly, of course. Now there is an application program. So from high level there is an application program that accesses the database by sending queries. So this terminology is now clear, right? So what we need is what we call as a query. From the database some subset of information we want, right? So that we will ask through some questions, like I want this, like this. So this is what we call as query. Or some request for data from the database. So user, by running some application program, Okay, so for example, when you are log into that K2 website, you can see some interface, right? Some K2 informations will be going on, a bulletin will be there where you can see all the updates, and some login area will be there where username, password, and that is the application program through which the user is interacting with the system. And when you are writing your K2 ID and password and all, you are getting access to your page, right? Your personal information you are getting access, and your score, mark, everything. So on background, not only your data, so Katie, you know that university, how many students data they are handling, so all the students data will be there in the database maintained by them, and from that database particularly they are retrieving your information, right? Like when you are giving your username and password, they exclusively selecting your information and they are giving that to you. So how this is happening? So that is about the querying, right? You queried that database for a specific data and you are getting reply for that. Okay. Now a query typically causes some data to be retrieved. So sometimes we will use the terminology that is somewhat equivalent to query only, transaction, but in it's having some wider meaning. We will see that a transaction may typically cause some data to be read from the database, and also for writing some information into the database. Other important functions provided by the DBMS include protecting the database. So DBMS is basically for constructing the database and also for manipulating, updating, querying the database. Those things we saw. In addition to that, this will do something like a protection. It will provide and maintaining it over some long period of time. Okay, so that durability it will try to keep. So protection includes system protection against hardware or software malfunction, crashes. So there will be hardware or software malfunction at any time, right? And that sometimes you may not get access to that KT website like that. So you can link with some of the application that you are familiar with it, and not only KTU, some other maybe IRCTC website, good example I can quote, like, and how you are when you are giving information like your starting point and ending point, accordingly they are listing all the trains availability, their booking status, everything, right? See how huge information they are handling at any time. So like that, right? So now some crashes can occur at any time, maybe some network failure or some hardware failure, software failure. And when such crashes occur, this database, maybe that you are storing it in some hardware, right? And that should not be lost completely, then the system is complete failure, right? There should be some way of recovering the information, maybe some, you may be keeping the copy somewhere, so is there any problem with this hardware, so that you can depend on the other one. So like that, there's some multiple copies you have to keep, that kind of things. And also security protection against unauthorized or malicious access. So you have your personal account maybe in different website and all, and someone else is trying to access your credentials, right? Some malicious program is written in such a way that they can get your password and they are trying to access, and that time the system should be able to protect that also, then only I can call it as a robust system, right? So protection from the hardware as well as software crashes or malfunction, and also the protection from unauthorized or malicious access, right? Some intruders trying to access your data, that should not happen. So we should get such a confidentiality, right? Then only, but still chances are there, but we will try to protect. So maximum protective measures should be implemented as part of our DBMS software. So day by day new attacks are being reported, and accordingly new protective schemes are also coming up, right? So that is how these things are evolved. Now a typical large database may have a life cycle of many years, right? Sometimes this IRCTC and all a lifelong we are using, right? So the DBMS must be able to maintenance is another one. So once you create and manipulate the data, it's something dynamic, right? Every time some new route will be introduced, some set of people are coming going like that. So that maintenance part is something another tricky thing. The database system, by allowing the system to evolve as requirement change over the data, maintenance of the database as well as the DBMS software is needed, right? So the DBMS software, according to the new trend, like maybe new attacks are being reported, and accordingly the software is to be updated and maintained, right? So that is the thing. So these are all the design constraints when we are having this DBMS software. But mostly, we have some strong robust software which are already developed by this IBM, Amazon and all, and we will be just using it. But anyway, these are all the constraints we are having on the background regarding the such a system, regarding such a system. Now the last terminology I just want to tell you is database system, right? So we already seen what is a database. Database is a collection of related data, right? Now this related data, how you are managing, like how to manipulate the data, populate the data, update it, query it, like that, all those things, and also how, what about its proper protection and all, everything is done by DBMS software. Now this database and the DBMS, database management system software, database is that collection of data. This is a software using which we are manipulating it, right? Is together called as a database system. Okay, so that is the last one. So this is how a simplified database system environment, you can see, like, so the whole thing is what we call as a database system, and inside database system, database management system software is there, right? And also the actual database is there. Now I already told you, along with the actual database we will store the minute description about it, right? So description of the database, or the database definition of the database, how it looks like, is what we call as a metadata. That also we will keep. So we have to store both the actual database and the metadata of it, right? So both are to be stored, and both are accessed through this DBMS software. And outside this DBMS software, or outside this database system, we have the user or the application program, the URL and all. You are seeing that graphical user interface part, and from that user or the program, the queries will be coming. So what they are interested, when you are giving your user ID and password, you are getting information about you, right? Maybe in KT website and all, maybe in case of IRCTC, when you are giving source and destination point, they are listing all the trains between them, their timing, their availability, everything, right? So such queries will be coming from the user or the program through which the user will send that query. Now yeah, that from the user or program, what is generated is what we call as the queries through the application program. Now this queries will be taken by the DBMS software. So the first part of the DBMS software will process the query or program. They will understand what is exactly needed, and what is needed, that is to be taken from the actual stored database, right? So for that there is another part which is interacting with the database and its metadata. That is the software part which to access the stored data. So this query will decode the requirement of the user, and it will correctly send the requirement to this part, and this will access the actual database, and from there it will take the data and give back to this software. Now from there it will be given back to the application program or user, and it will be presented in a good way using some graphical user interface, right? So that the user can understand clearly. So the way in which data is being stored in the database and the way in which the queried data is displayed to the user, both are entirely different. So the presentation also matters. So there also some other software we will make use of. Okay, so all those things we will see in much more detail in our subsequent discussion. So hope we get an overall idea about. So the things we explained so far in part 1 and part 2 is like what is data, what is database, what is database management system, and what is database system as a whole. Okay, the collection DBMS and database together we call as database system. And what is this query, transaction? Some minimum understanding you are having right now, right? How to, what are all the implicit properties of database management system, many things we saw. And what is this metadata, and what is this DBMS catalog, right? And what is mini world? Okay, so keep all those in your mind. Just so it's very easy thing so far. The tougher parts we are just going to enter only. Yeah. Okay, thanks for watching, and any doubts you can clear during our offline classes.